We're talking margin of error today. So let's think about sample and population. So remember way back, we talked about the difference between a sample and a population. And we said that it's almost impossible to get an entire population. You know, we have a school that's small enough, we might be able to just take all of our students' GPAs and average them, right? And we could just put them into a calculator. But truly, what if we wanted to find the average GPA of every kid in the country? Like, is that really realistic? I mean, we don't even have a way that we could collect all of that data, let alone calculate it, right? So oftentimes we cannot use a population because we can't gather data from that big of a group of people. So what we do is we try to find a sample, a representative sample of the population. So we would say, let's get this many juniors, this many sophomores, this many freshmen, this many seniors, and we're going to calculate their GPAs, and we're going to assume that that represents the entire population. Now, because we do this that way, a lot of times you have something called a margin of error. So oftentimes, the numbers that you calculate are close to the population mean, but not exactly. So let's say that we found a mean, actually, let's just look at this example in front of us. You have an average height. So we took a sample of men and found that their average height, their mean height was 175 centimeters. So what we found is of these 40 men, their average height was 175 centimeters. And what we're thinking is if this is a representative sample of men, then we're pretty confident that the population mean is going to be somewhere near 175. It's not going to be exactly 175, right? Because these 40 men that we picked don't exactly represent our population. They just represent as much of our population as we possibly could, okay? So we have this thing called a confidence interval. Don't freak out by that name. It's not a matter of like, we don't even have to think about what it is, but basically the idea is we are pretty confident, and in this case, this is a 95% confidence interval, but basically what it says is we're 95% confident that if we were able to measure every single man in this entire population, that the mean height would be 175 centimeters plus or minus 6.2 centimeters. So what we're saying is it would be close to 175. In fact, we believe it would be between, or it would be within 6.2 centimeters of 175. So here's our mean, 175 of our sample. And we say, if you went 6.2 centimeters to the left and 6.2 centimeters to the right, we are pretty confident that the actual population mean is somewhere between these two numbers. So the numbers are somewhere between 168.8 and 181.2. This is what we call the margin of error. So this is how much we believe we may have erred in our data collection. And in this class, we're not actually going to calculate the margin of error. We're just going to say, when we have a margin of error, what does it actually mean? Because we're coming up on an election year, and I know that most of you aren't old enough to vote yet, but you're going to be given these statistics all the time. Okay, so they're going to say this person is in the lead with 51% of the votes, or 51% of the polls say that this person's in the lead with a margin of error of 4. So what does that mean? That means that we're pretty confident that 51% of people are going to vote for this person, but it could go 4 this way, and it could be 55, or it could go 4 this way, and it could be 47. And that's what happens, and has happened in many elections, is that the margin of error for these are so close that they actually overlap, and someone else ends up winning that nobody expected to win, because the margin of error actually says, 51 isn't exact. 51 is like probably, okay? So let's figure out what this means. Here we have a study with the Department of Education, and we're trying to determine the mean SAT scores for graduating high school seniors. We found that the mean score was 449 with a margin of error of 15. And so then it just says to create a confidence interval and give us a reasonable value for the true mean SAT score. This one comes from Delta Math, and this is actually a multiple choice question. So you would select which one you thought was a reasonable value. But the first thing we do is create a confidence interval. And all a confidence interval is it says, okay, here's the sample mean. This is what I got when I sampled people. And I am pretty confident that the actual mean of every SAT score in the entire state is within 15 of this. So I'm going to go this way 15, and I'm going to go this way 15. And so my confidence interval is going to start at 434, because that's 449 minus 15, and it's going to end at 464. So what I'm telling you is that the actual mean of SAT scores is very, very likely in between 434 and 464. So then you could pick from a reasonable value, and in this case 457 or 459.7 is in between 434 and 464, right? So this is a reasonable value. This very well could be the mean of all high school seniors in the population.